Welcome to This Explainer. Okay, picture this. You glance down at your phone right now, and there's a global emergency alert glaring back at you. A massive, civilization-ending asteroid is on a direct collision course with Earth. You don't have years to prepare. You don't have generations to engineer some massive, complex solution. You have exactly 30 days. Today, we're diving straight into the raw science of an impact event, mapping out exactly what would happen to our planet, our society, and our environment.
So the clock is ticking. The threat has been verified by every major space agency on the planet, and there is absolutely no stopping it. 30 days. I mean, in astronomical terms, that's just a blink of an eye. It completely wipes out our ability to launch any long-term mitigation strategies. We're not talking about some Hollywood blockbuster where we send a ragtag crew up into space to drill a hole in the rock. No way. We are talking about an unavoidable, catastrophic force of nature just barreling towards us in the dark of space.
Section 1. The countdown to disaster.
Day 30 hits, and we have discovery and verification. Fast forward just 5 days to day 25, the news breaks globally, and we'd see immediate bank runs and total supply chain collapses. By day 20, you're looking at massive societal shifts, entire populations desperately fleeing coasts and major cities. And by day 10, inevitability really sets in. Sure, scientists might frantically drop space deflection techniques. We're talking about ideas like launching kinetic impactors to crash into the rock to alter its path, or deploying gravity tractors to slowly pull it off course. But honestly, with only 30 days on the clock, the sheer scale of those operations makes these interventions mathematically impossible.
Section 2. Calculating impact energy.
To truly understand our fate here, we have to look at the undeniable math. The destructive force isn't just about how big the rock is. It's calculated by combining a few very specific variables. First, scientists have to calculate the object's mass, so figuring out its volume and its incredible density. Next up is velocity. These objects are traveling at tens of thousands of miles per hour. When you multiply that massive weight by the square of its blinding speed, you get its true kinetic energy. And finally, the angle of impact matters. A steep, direct trajectory transfers maximum energy straight into the Earth's crust, which basically ensures total destruction.
And the result of that terrifying equation? An impact energy equivalent to 100 million megatons. Let that sink in. That number just completely defies human comprehension. To put it into perspective, it's equal to millions of the most powerful nuclear weapons ever detonated, all going off in the exact same fraction of a second in the exact same spot. The Earth's crust wouldn't just crack from that, it would literally liquefy and vaporize. But here is the crazy part. That initial kinetic energy release is really just the spark. The true test of human survival isn't the explosion itself, but what the world actually looks like in the hours and days after the dust settles.
Section 3. The Great Impact Day.
Day 0 is a rapid, terrifying domino effect. Step 1 is the impact flash. Temperatures spike hotter than the surface of the sun, instantly vaporizing rock and carving out a massive crater. Step 2 is the global shockwave. Imagine a solid wall of compressed air moving outward at supersonic speeds, just flattening forests, buildings, and entire mountains for thousands of miles. Step 3, continental firestorms. All that superheated debris ejected into space falls right back down, superheating the atmosphere and igniting literally anything flammable across whole continents.
Section 4. The harsh winter and consequences.
Because that initial explosion, that was merely the opening act. What follows is an impact winter. This happens because all that vaporized rock, the ash, the soot from the global firestorms, it all gets trapped up in the upper atmosphere. It creates this incredibly thick, impenetrable blanket over the Earth. The sun's rays literally cannot reach the surface anymore, plunging the entire planet into a deep artificial freeze.
Let's break down that timeline. Day 1 brings a total stunned silence across whatever's left of the globe. By week 1, that atmospheric dust has fully blocked out the sun, turning daytime into this permanent freezing twilight. And by month 1, the reality of zero sunlight leads to universal crop failures. Photosynthesis just completely stops, and the foundational pillars of the global food web crumble to dust.
Think about the Earth we know right now, a place where sunlight drives our agriculture and effortlessly supports billions of lives. That world is gone. It's rapidly replaced by a frozen wasteland choked by atmospheric dust. Without the ability to grow food, the slow creep of starvation actually becomes a far deadlier threat than the asteroid itself ever was. Yet even amidst all this profound despair, human adaptation slowly begins to take root in the dark. It's kind of amazing. We'd see extreme rationing. We'd see deep adaptation, like moving entire populations underground near geothermal heat sources just to stay warm. We'd see incredible scientific rescue efforts, like figuring out how to cultivate fungi or using artificial lighting for tiny, life-saving indoor crops. The sheer ingenuity of our species would be put to the ultimate test.
Section 5. A new dawn for humanity. Very, very slowly, gravity and precipitation would start to pull all that soot out of the sky. The survivors who eventually step out of those bunkers and caves, well, they'd be stepping onto a drastically altered planet. The population is just a tiny fraction of what it once was, and the geography, totally unrecognizable. But as a pale, weak sunlight touches the freezing ground for the first time in maybe a decade, so does the opportunity to start over, to rebuild civilization piece by piece.
You know, we spend so much time marveling at our rockets, our supercomputers, our incredible infrastructure. But when faced with the cold, unstoppable math of a 100 million megaton impact, what if our greatest power isn't actually our technology? What if it's just our sheer, stubborn ability to survive? Thank you so much for exploring this scenario with me today. Keep wondering, keep learning, and I'll catch you in the next explainer.